Okay, so let's have a look at example 7 now. So in this one, we're asked to find the equation of any asymptotes to the graph. So the first thing I would recommend that we do for the question is to factor. We want to factor this a little bit. So just factoring a little bit here, let's take out that x at the front, and we're going to get x squared plus 4x minus 12. And then on the bottom, x squared plus 7x plus 6. Next, I'm going to factor the two quadratics. So here we've got negative 12, and we need positive 4. So that's going to be 6 and minus 2. So g of x now is going to equal x bracket x plus 6, x minus 2. Minus 2 times 6 is negative 12. 6 minus 2 is positive 4. This one on the bottom, we've got two factors of 6 that have to add to give 7. So that's easy, that's x plus 1. So that's 6 plus 1. So we get x plus 6, x plus 1. Can we see a vertical asymptote here? Do we have two vertical asymptotes, or do we have one? Or do we have none? We have one. Where is the vertical asymptote? So we have a vertical asymptote at x equals where? Negative 1. We don't have an asymptote at x equals negative 6. That's a hole. Because the multiplicity of the factor is the same in the numerator and the denominator. So those are all the vertical asymptotes. Do we have any horizontal asymptotes?
No.
Why not?
Because the top is
P is greater than the degree of the
Try not to check out quickly all the time. Okay, we can see that there's no horizontal asymptotes here. Why? Why can we see there's no horizontal asymptotes? We can see we're going to have a slant asymptote, not a vertical asymptote, because the degree in the numerator is greater than the degree in the denominator. So I might just sort of say no horizontal asymptote. And then lastly, we need to find this. So we need to find the equation of this. This is going to be a little bit trickier. It's going to be a bit trickier. We're going to need x cubed plus 4x squared minus 12x plus 0. Add in any terms that are missing. We're going to divide that by x squared plus 7x plus 6. Thank you. I'm in a bad week. So we are looking now. Sorry. We are looking now. What do we multiply x squared by to get x cubed? We're going to multiply by x. And then write it over here in this column. Keep terms of the same degree in the same column. So x times x squared will give x cubed. X times 7x will give 7x squared. X times 6 will give plus 6. At this point, we do the subtraction. X cubed minus x cubed, they cancel. 4 minus 7, negative 3, x squared. Minus 12 minus 6. Sorry, minus 12 minus 6, minus 18x. And then we can drop down the last term. So now we ask ourselves, what do we multiply x squared by to get negative 3x squared? What do we multiply x squared by to get negative 3x squared? Negative 3. Now, I could fill in the rest of this, but I don't need to, because the question is asking for the asymptote. I have the slant asymptote, y equals x minus 3. So the question is asking for find the equations of any asymptotes, and we have 2. This is the answer. Let's have a go at 2 past paper style questions. Past paper style questions now. Alright, take a couple of minutes to have a go at this question. I'll pause the video here at this point. Work it out with the person next to you.
So will we calculate slant asymptote in case we don't have the horizontal asymptote?
Yeah. Well, if there is one. We could see that there was one because the degree in the numerator was 1 more than the degree in the denominator. So we knew there'd be a slant asymptote. Sorry, let me just pause the video. Sorry. Let's have a go. Okay. Maybe it's my answer. So we have D is given there. We got function D. Which of the following about the graph is correct? Ooh. So it has 1 horizontal asymptote, 1 whole, and 1 vertical. So, all right, let's just identify what it has. In order to identify that, we have to factor the denominator. So for this question, you have to start by factoring the denominator. We've got 2. They've helped us a little bit, and they've factored the numerator. But we are going to need to factor here. That's going to be x minus 1, x minus 1. Let me just check that in my head. Yep, that one's good. Do we have a 0?
Yes.
How many zeros do we have?
2.
We have 2 zeros. It's 0 and -4. Now, all this x minus 1, is that a whole or an asymptote or both?
And you can't have both because the vertical asymptote will fill the hole. So it's only a hole. Oh wait, no, sorry, it's only a vertical asymptote.
It's going to be a vertical asymptote. So you can't, if you think about it, you can't have a whole and an asymptote because an asymptote is a whole. So once you get an asymptote, you get an asymptote. Asymptotes are the big layer here, and they will always cancel out everything else. So we are going to get 1 asymptote, we're going to get 2 zeros and 1 vertical asymptote. Do we get a slant asymptote? Well, why do we get a slant asymptote? So we are getting 2 zeros, 1 vertical asymptote, no horizontal asymptote, and then 1 slant asymptote. Why are we getting a slant asymptote instead of a horizontal one? The degree of the polynomial in the numerator is x to the power of 3, and the degree of the polynomial in the denominator is x to the power of 2. As the degree in the polynomial in the numerator is 1 more than the degree in the denominator, we will have a slant asymptote. So which one of these says that? We need 1 slant, no holes, 1 vertical. It's this one, isn't it? 1 slant, no holes, 1 vertical. Okay, last question. Oh, sorry, did I answer your question? Okay. Have a go at this question now. Okay, so here are the information. We'll have to sketch the rational function. Do we have a vertical asymptote? Where is the vertical asymptote? What's the equation of the vertical asymptote? X equals -1. So let's put this in first. We have a vertical asymptote here. The equation of that is x equals -1. Always label your vertical asymptotes with their equation. Always write the equation. So that is what it tells us a little bit here. Now, how do we approach the negative asymptote? It tells us that we approach the negative asymptote from the left, we go towards negative infinity. And when we approach from the right, we also go towards negative infinity. So this statement here tells us that the curve is doing this. This statement here tells us that the curve is also doing this. Let's fill in the other statements. So this statement here tells us that we are exiting off down in that direction. This statement here tells us that we are exiting off in this direction. Now, it's a rational function. It doesn't tell us much else about it, so we can't. It's a bit tricky to sketch. But this is the important information. So as long as we meet that, then a rational function could do this. It could do this. It could look something like this. This would have an oblique asymptote. So there are other options that this could have, but let's say, for instance, we had an oblique asymptote over here like this. Then the curve could do this. And it would look like that.
Nope.
Alright, that's it for this.